accessing climate data through CalAdapt. My name is Nancy Thomas, and I'm the director of the Geospatial Innovation Facility here at UC Berkeley. And I'm here with our lead web developers, Shruti Mukhtiar and Brian Gailey. We will hope to answer all of your questions today. And I also want to introduce Lucy Andrews, who is a graduate student researcher working with us. And she'll be handling the chat box and any questions you might have today. So feel free as we're going along to raise your hand, ask questions. We really are looking for your feedback. And we'll stop and have questions as we go through the webinar today. So I hope that none of you hear the terrible noise in the background. Here at UC Berkeley, there's some construction going on right underneath us. So we all feel like we're at the dentist's office, but hopefully that's not really affecting you guys. So hopefully that will go smoothly. So thanks again for coming today. What we're going to be talking about is ways to access data through CalAdapt. So one of our main goals here at CalAdapt is to make climate data accessible and actionable. So we want to make it useful information for a wide variety of people who are doing all sorts of things looking at climate resilience and adaptation. So we're really excited to introduce our new tool. Before I go too far, I do want to talk just a little bit about CalAdapt in general. We are a web application that is built here at the Geospatial Innovation Facility. CalAdapt is designed to link complex climate science with practitioner needs. So again, making climate data useful and actionable for a variety of users. The development of CalAdapt is supported by the California Energy Commission. And we recently have received funding as well from the California Strategic Growth Council. So we want to thank both of those organizations for their oversight. We also have a technical advisory committee, both past and present, who have been very, very helpful with oversight and guidance in guiding our development here at CalAdapt, so we want to thank them as well. And then I do want to mention that CalAdapt, what we do here is we host climate data that's been created by researchers throughout the state of California. So we at CalAdapt do not actually create the primary data. We are hosting data from other researchers and making it more accessible and easier to use. So we always want to thank the many partners who actually are doing the modeling work to create the data that we put onto CalAdapt. So with that, I'm going to talk a little bit about what we're going over today. So today's workshop is a little bit different than some of the other ones we've had in the past. As many of you know, CalAdapt is a tool for exploring California's climate change research. And the website is sort of broken up into climate tools, where you can visualize, you can look at your own area of interest and really visualize how climate is projected to change in your area. And that's what we spend a lot of time on our past webinars. We've looked at individual climate tools. Today we're really focused more on the data part of it. So how do you access climate data to do your own analysis? Maybe you want to do your own research with climate data. Maybe you want to create your own charts and graphs that are a little bit different than the ones that we present. So what we're going to be talking about today is how to do that and make that easy for people. So with that, I'm going to talk a little bit about the web architecture of CalAdapt. I'm not going to go into this in too much depth, but I think it is really helpful for people to understand where the data is and what the capabilities of working with the data are. So one of the things that we're really excited about with CalAdapt is that we have built a free and open application programming interface, or API. Now, an API can be thought of as a cog that allows two different systems to interact with each other. So in this case, the API is allowing your web browser, so the web browser on your computer, to interact with the CalAdapt server, where all the data is held, and to interact with the features of the API. So that's important because it's through the API that we have created a lot of this functionality to allow you to download climate data in many different ways. So there's a lot of different ways that you can access climate data through CalAdapt. And we're going to talk about a few of these today. So again, one of our main goals is to make climate data easy for people to use. Climate data can be quite complicated. It's very large files. A lot of times it comes in formats that people don't really know how to work with, like NetCDF. So our role is really to make that data easier for people to use. And we do that in several different ways on CalAdapt. So the first way that people can access data is really, in some ways, the simplest way. So the easiest way to get data through CalAdapt is actually directly through those climate tools. And I'll show that in a few minutes. You can actually download tabular data as well as charts and graphics directly through each of those climate tools. And in a lot of ways, that's sort of the easiest way to get data through CalAdapt. And again, we'll talk about that a little bit more in a few minutes. We can also access the API directly. So the second window there, if you are someone who's comfortable writing some computer code, so if you're comfortable with Python or JavaScript, you can actually access the API directly, and you can customize your data as much as you want. So that's for people who are comfortable with writing at least a little bit of code. And then, I should mention that we are adding the capability to work with R, to work directly with the API through R. So that's something that should be coming soon. I know there's a lot of R users out there. And then really the third way of accessing climate data is through this new tool that we have been working on over the past month, and that's our new data download tool. So a couple great things about the data download tool is that you can actually use many of the features of the API. The API really is allowing you to slice and dice your data in different ways. So the data download tool allows you to use some of those features without actually having to write any of the computer code yourself. So we're really making that access to the functionality of the API available in an easy, hopefully easy to use format. And you can also access the primary source data through our data download tool. Some of the new features in the data download tool that we've really heard from a lot of users. With CalAdapt, we're always trying to improve CalAdapt. We're always building new tools. And we really have been doing a lot of user outreach. So we really have been listening to what users are requesting. And this tool grows directly out of that. So we're trying to build in features that we've heard users have requested. So that's where this tool comes from. So one of the great new things about this tool is that we can now download data from multiple locations in a single process. Through the climate tools, you can only download data for a single location at a time. We had a lot of users request this multiple location capability. So that's one of the things that we've built into the new tool. We can also temporarily aggregate data now, and we'll go over this a little bit as we go through the webinar. But one of the features of the API that I talked about is that it has the ability to aggregate data in different ways. So a lot of the primary climate data is in a daily data format, but a lot of people don't really want to look at daily data. You might want to look at seasonal information or decadal or monthly, and now we can allow you to easily do that. Another really cool thing is that we can convert units. This is something that people have also requested, and we'll go over that when I show you some of these capabilities. We've added some new data sets. There is now wind speed, solar radiation, relative humidity. Those are new data sets that you can now access through the API that were not available earlier. Another great thing is that we can now download multiple models and RCP scenarios at a time. So again, these are things that people have asked us to make their life easier. So we've been implementing some of these changes across this new tool. And then we've also made the entire data catalog searchable. So part of the data wrangling on our end is taking all of this disparate climate data that's on CalAdapt and making it putting it into a format that is easily searchable. So those are some of the new features, and I hope that you are all excited about some of them. A little bit more about some background information before I jump into showing you the tool. I do want to clarify how we store and host climate data here at CalAdapt. So there's actually two different storage systems that we use for different data sets. So we have a CalAdapt data server that's actually a physical server here at the GIF. And on the data server, we store the original source files that are provided by research institutions. So, for example, most of the climate data comes in NetCDF format. So we host the original source data in NetCDF format. And we make that accessible through these tools. So if you want to download data to do your own processing and your own research, you can grab that data through our data download tool and through the API or through this data server. So some of those data sets are only on the data server. So, for example, the full set of the 32 global climate models that have been downscaled by LOCA are all available on the data server. So if you actually want to work with the full data set, you can grab the NetCDF data, download it, and use your own tools. Now, a subset of the climate data on CalAdapt is data that we use to build those climate tools and visualizations. And that data is uploaded to our high-speed virtual server on Amazon's cloud. So that's how we make that data really fast and interactive in our web-based tools. So again, if you go to CalAdapt and you are playing around with the climate tools, you know that they're all very interactive. You can enter in your own area of interest, your own thresholds, and the way that that is fast and interactive is by hosting it through the virtual server at Amazon. And the API interacts with that and allows us, again, to really slice and dice all of this data in different ways. So you can slice it in different temporal or spatial aggregations. And again, that's what really allows us to do this fast, interactive web application that people are used to. So within the server, within the virtual server, and within the API itself, we are serving up a subset of the climate data. So, for example, with LOCA, which I'll just talk about in a minute a little bit more, we are serving up the 10 models that have been recommended by California's Climate Action Team Research Working Group. See, I spelled that wrong. As well as many other different climate layers. But that's a subset of that entire data set. So if somebody wants to work with the full data set, they can go and download the NetCDF data. We are working with the recommended models within the API, and I'll talk a little bit more about that. I'm not sure if we were doing this in a live presentation, I would ask people to raise their hands so I could know how many of you are already familiar with the LOCA data set. LOCA is really one of the key data sets that we host on CalAdapt. LOCA stands for Localized Constructed Analogs, and it's a statistical downscaling process that has been done at Scripps Institution of Oceanography, and it's downscaling the global climate models from the CMIP-5 archive. So as I mentioned, there are 32 global climate models that are available through LOCA. The time horizon, there is a historical modeled period from 1950 to 2005, and then there's also future scenarios. So we're looking at projected climate data from 2006 to 2100 or 2099, depending on which exact model. So for each of these models, there are also 2 emission scenarios that we're hosting on CalAdapt. There's the RCP 4.5, which is a lower emission scenario, and then there's RCP 8.5, which is more your business as usual scenario. Of the LOCA data, the spatial resolution is 1/16 of a degree, which is approximately 6 by 6 kilometer grid cells. With the LOCA data, the time step is daily, so it's a daily data set. And there are several variables that are available. There's the maximum temperature, minimum temperature, again per day, and then precipitation. And then some of these additional variables have been modeled by LOCA, the relative humidity, surface solar radiation, and wind speed. And again, those are just newly made available through CalAdapt. I know we've had several users that are requesting those data sets. So we also have other, LOCA is one of the many data sets on CalAdapt. As I mentioned, it is probably one of the key data sets. LOCA was really the basis of most of the climate information that went into the California Fourth Climate Change Assessment. So LOCA is a key data set. But each of these different climate data sets that we have on CalAdapt will have basically some of these same things. There will be a time horizon, an emission scenario, a GCM or model, and a time step. So those are important things to think about as you think about what type of data you want to access. Just a little bit more about those 10 models that I mentioned. Out of that 32 GCMs that have been downscaled for California, there's a lot of work trying to sort of subset that data into something that's more usable. So if you want to work with that full 32 set of models, it's a lot of data, and a lot of people don't have enough compute power to really be able to wrangle that much data. So in preparation for California's Fourth Climate Change Assessment, the Climate Action Team Research Working Group looked at each of those models and picked 10 models that have a particularly good simulation of California's historical climate. So those are basically the models that are best representative of California. And those are the models that you can get through the CalAdapt API and that are shown on each of our tools. Out of those 10 models, even working with just 10 models is a lot of information for most people and can be a bit confusing. So beyond that, there was a subset of 4 priority models, which you see highlighted here. So those 4 models were chosen to represent a range of possible futures out of the 10 models. And those are the ones that are, we default to those 4 models on our CalAdapt tools. So I just wanted to clarify that a little bit. There's also some papers that have been written. So if you're interested, I think on each of our tools, we link to the papers where the discussion is written about how those models were selected. So there's certainly more information than what I'm showing you here about that model selection, if that's something that you're interested in. So with that, I'm going to jump in and introduce the new tool. But before I do that, I would like to just spend a minute and see if anyone has any questions at this point. And I'll just give you a minute. Again, feel free to type in the chat box, and we'll just give it a minute if anyone has any questions. Nobody? All right. Well, hopefully we'll generate some questions before the end of today. So I have just gone to CalAdapt, cal-adapt.org. This is our homepage, and again, we organize the data into these climate tools, download data, and finding resources sections. I do want to mention we always have our new tools highlighted as well as new data sets in case you just want to see what we're working on at CalAdapt. You can see those things highlighted. The first thing I want to do is actually go through the climate tools. As I mentioned, the easiest way to download data is actually directly through the climate tools. So I'm going to talk about that first, and then we'll go into the new data download. So as many of you know, we have many different climate tools on CalAdapt. If you're interested in things like the annual averages for maximum, minimum temperature, precipitation, we have extreme events, sea level rise, snowpack, wildfire, cooling degree days, stream flow, drought scenarios, and hourly projections of sea level. As you know, we're always building new tools in CalAdapt. I'll talk a little bit about what's coming up at the end of this webinar, but we're always interested in hearing from you what new tools you would find interesting and helpful. So I could pick any of these. I'm just going to go ahead and grab the snowpack first. This is one of the tools that has an animation included in it. Normally I would show that off, but right now what we're interested in doing is just really showing you how you can easily grab the data from this tool directly. So what this is looking at is snow water equivalence, which is related to the snowpack. And this tool is aggregated into monthly information. So again, this is actually started out from a daily data set that we've aggregated to monthly. So a lot of times what people are interested in is looking at the snowpack, how much snow is there at the end of April. So that's sort of how we've built this tool. You can, of course, as a user, change to any month you're interested in. But April is a pretty standard month for looking at snowpack. With all of these tools, I mentioned we're looking through this time series. The gray line is our observed historical information, and then these colored lines are our modeled projected data. As I mentioned, these tools show the entire set of 10 recommended models, and then we default to the 4 models that are used most often to look at this full range of climate conditions. So that's what our default is, and I'm just going to leave that for now. We can always change location. Right now we're defaulting to a grid cell around Tahoe. With all of our tools, of course, you can change location and look at whatever you're interested in. So we have many preloaded boundary files, and then you can also upload your own shapefile. I'm going to show you that in a few minutes with the data download tool. Right now, I'm just going to pull up California's 4th climate change assessment regions. So these are the regions that were used in the report for California's 4th climate change. And as hopefully most of you know, you can select the area that you're interested in, say Update Chart, and then my chart dynamically updates for me. I can change the RCP, so I'm going to look at RCP 8.5. So I'm looking at the Northern Sierra region. You can see precipitation is really expected to continue to be quite variable in California, but there is a downward trend over time. We can look at our quick stats, which show our annual mean for our historical data versus our annual mean from averaging these 4 models together over the end of century time period, 2070 to 2099. But the easy way to download data or to access data, one way is to actually just save this chart itself. So a lot of people really just want to look at these climate tools and download this chart itself and put it into a presentation or PowerPoint. And that is really easy to do. So you can always just save out these charts themselves. You can also save if there's a download data button. And if you click on that, what this is doing is actually downloading the time series that you have selected in the tool. And this is really the easiest way to access a CSV file of your climate data from whatever tool you're looking at. So this is giving us the value, the units in inches. It's telling us what RCP we're looking at. And it's giving us this Livni data is the historical. And as you scroll down, you'll see you get information from each of these models. So we're looking at those 4 recommended models. So you'll see all 4 of them in this CSV file. One thing we just noticed is that this date is showing up a little bit wrong. We need to fix this. What it's telling us is the last 4 digits are the year. So this is 1950. And this is from April, so the 4th month, the 1st day. And we'll go in and change that so that this is showing the correct date form. But that's what that information is showing. So again, this is really the easiest way to grab climate data from CalAdapt. And you can do this with any of the different climate tools. So I wanted to make sure that everybody was aware of that. I don't need to save it right now. Again, you can do that with any of your different climate tools. So with that, what we're going to do is start looking at the new download data tool and go through some of these capabilities. So we do have it broken into, different getting your climate data and downloading data, or as I mentioned earlier, you can work directly with the API. And I'll talk a little bit about that at the end of the webinar. But what we really want to look at is this download data. And we'll go over the different capabilities. So there are 4 different steps that you're going to do using this tool. Searching the catalog, selecting what format you want your data in, selecting what location you want, and then selecting the model and downloading the data. And it walks you through those each. So we have a couple search functions, which I'll show you in a minute, and some filters that you can look at to select the data set that you're looking for. You can also just scroll through. As I mentioned, we're always adding new data into CalAdapt. So these are the data sets that we have available now. There's many different data sets. There's CalFlood 3D, which is a coastal flooding data. We have gridded observed data, so that's really that historical data. So you can just sort of scroll through these and see what these different data sets are. You'll notice that for each one, it also is telling you what are those variables that you can get from that data set. For example, VIC is that LOCA data that's run through an additional hydrological model. And all of these different variables are available through that VIC model. So again, you can just sort of browse what's available, or you can search for data in different ways. For example, you can look at this filter to look at climate variables. So perhaps what you're interested in is precipitation. And you can see which data sets have precipitation data. And then you can pick which data set you're interested in from that. We also have information here on the publishers. If this is something that you're interested in, certainly a lot of the data comes from Scripps, but we also have data providers at these various other locations as well. You can clear your filters, and then we can also search. So for example, what I'm going to demonstrate today is the LOCA data. So I can search for that, and then it will come up with all of these LOCA products. And the one that we really want to focus on is this LOCA downscaled CMIP5 climate projection. So again, this is really the key data set that has been used for the fourth climate change assessment, and for many of the other modeling has been done on top of this data set. So this is really one of the key resources in our data catalog. So I know that I want to look at LOCA. I'm interested in looking at maximum temperature, so I'm going to select the LOCA data set. So this is now we're on step 2, select download format. So once you select the data set that you're interested in, you'll see that you have a lot of information about it. So we have the publisher. This was published by Scripps. We have a brief description of the data. It tells us what variables are available. So those are the different climate variables. It tells us what scenarios. So in this data set, we have historical modeled. We also have RCP 4.5 and 8.5. It tells us what GCMs are available. And then there's always reference information as well. So if you click on this, this is what you would use to cite this data set. And this is the report written for the fourth climate change assessment on this particular data set. So those are all easily accessible once you choose your data set. And then you'll see over on the right side, this is where you select the data format that you want to use. You may remember I mentioned that we have this CalAdapt data server where you can download the primary source data itself. So if you wanted to work with all 32 models, you could go here and download the models themselves. So that's always an option. Again, that is in NetCDF format. But if what you want to do is work with the API and really have an easier way of grabbing some of this data, you would use this spatial subset from the CalAdapt API. And you'll see there's two main formats. We have raster format or tabular format. And you'll see that they're a little bit different, some of the options that are available depending on which of these you choose. So we'll go through both of them. What we're going to do is start with the raster format. So what this is going to give us is it's going to output GeoTIFF files for us. So if you're a GIS user, or use some other, geospatial software, this might be the format that you want. So if you want something that covers an entire region, if you want the actual pixels, this would be how you would do it. So the next thing you do is select the extent you want. So we have many different options. You could just draw directly on the map. You could select a feature from our preloaded boundaries. So if you're interested in counties, places, if you're interested in cities, that's what this would be. You could find individual cities, census tracts, or watersheds are the key polygon files that we allow you to aggregate data on. Or, of course, you could upload your own file. And that's what I'm going to show you right now. So I click on that button, and it'll tell you what formats are supported for uploading files. There is a limit, so we do, it is computationally challenging to process a lot of this data. So there is a maximum area, 20,000 square miles. I haven't actually tested that, but I'm sure that it works. I have a shapefile that I have created. So you'll see that it says you can upload zipped shapefiles. So I'm going to browse. So for those of you who are GIS users, that makes perfect sense to you. For people who maybe are not familiar with geospatial data, this is my shapefile. Shapefiles actually are made up of several different files, which is always confusing to new users, but shapefiles are made up of several files with different extensions. So if you want to upload a shapefile, what you need to do is to zip it into a single file. So that's what I've already done. So I have a Sierra subalpine.zip. So this is a study area that I'm interested in. I was using the ecoregions layer and looking at a particular subalpine ecoregion, so I can just upload that. And it's telling me that my file is valid. So if it were not a valid shapefile, if it didn't have the key pieces that were needed, you would get an error message here. And then we go next. So once we've selected the area that we're interested in, now we can aggregate the data in the way that we want. So if you can scroll down and see what is showing up. So remember, we've selected the LOCA downscaled CMIP5 climate projections. So right now, it's telling me all of the different raster time series that are available for that area. And you'll see that there's actually many, many data sets. In fact, we have 228 series. So when we talk about series, what that means is a combination of your climate variable, your model, and your scenario, and your resolution. So you'll see as I go through and I select the ones that I'm interested in, that will filter out the data. So the first thing we want to do is choose which climate variable we're interested in. So again, we could choose any of these different variables. Right now, I'm just going to go with maximum temperature. I can also choose which model. So here we could choose an individual model from those 10 priority or 10 recommended models. I usually work with these 4 priority models. They've really been selected to represent the range of the full models. So I personally find it much easier to just think about those 4 models. So that's what I would start with. And then you can pick which scenario you're interested in. So do we want to start by looking at the historical model data, the low emission scenario, or this RCP 8.5, which is our high emissions business as usual. So I'm going to choose the RCP 8.5. And you'll see that we now have, this has really filtered out our data set. And now we really just have 8 series to consider. Now we get into the temporal resolution. So as I mentioned, this data is daily. The original source data is in a daily time step. But that's a lot of data. I personally would not really recommend downloading raster data at a daily time step, although one can depending on your needs. A lot of times if I'm going to look at the raster data, I might want to aggregate it. So what I'm going to do is tell it that I want to aggregate that daily data into annual data. And now we have just four time series that are remaining. So again, each of these are maximum temperature as my variable. It's showing 4 different models. These are the 4 priority models, and it's telling me that they're all 8.5. That's the RCP 8.5, high emissions, business as usual. We have information here, again, about the resolution, so I know I'm looking at annual data, and the begin and the end dates. So we're looking at projected data beginning in 2006, going to 2100. And now you can select multiple, this is something we're really excited about. We used to just be able to do one at a time. Now you could select all 4 of these. Just for the demonstration purposes, I'm just going to select 2 models, and then you download. And I'm just going to open it up right now so you can see, oh no, I actually want to save it. Sorry. You can see, we'll leave it with that name. Downloading, it's pretty fast. And now I can go and show you what is in that file. So this is its name. I'm going to, it's a zipped file that you're going to get. I'm just going to extract it just so I can show you what it's going to look like. So it's going to give you a data folder, and it's going to give you a whole bunch of data. So again, this is raster data. So what it's doing is downloading a single GeoTIFF file for each year for each model. So as you can look at this data set. So this is telling us again that the variable is the maximum temperature, the name of the model, the RCP 8.5. It also tells you in the name of the file the loca run. So this was actually run in 2016. It was generated. So that's really helpful to have if, there's always improvements to these modeling efforts. So if loca itself changes and there's a new modeling run, you'd be able to know which data set you were working with. So again, as a TIFF, as a GeoTIFF, it's downloading individual GeoTIFFs for each year. So the first one's for the 2006, second one's 2007, and it goes all the way, again, for both of the models. So this is your CAN ESM2, and then we also downloaded the HADGEM2. So again, I just wanted people to sort of understand what output they're going to get if they use that particular raster format. You could do a lot with this data. If you have, a GIS software, you could now open that data up into GIS. You could then aggregate the data in whatever way you want to. Right now it's annual, but maybe you'd want to look at decadal, or you want to look at your own 30-year time chunks and average over that time period. You can do all of those things using GIS software. So that is one way. We can also then unselect. So that's how you would download raster data. What we find, though, is that what most users have requested is a tabular data download that allows you to aggregate in different ways. So what I'm going to do next is show you the tabular data. So you'll see I just went back to the second step. I already know what data set I'm working with. I want to continue looking at the loca data, but now I want to change my download format. So we just were looking at raster. Now I want to look at tabular. And the second step, again, is the spatial extent. So once again, I can upload my own shapefile, or I can upload my own CSV file. So with this approach, one of the things that people requested is, people don't necessarily want to use shapefiles or other geospatial formats. A lot of people just want to be able to upload a CSV file that has point locations, and then extract that data for those point locations. So that's what we are enabling. So I'm going to use a file that I included. Right now we have some limits on the size. Right now we're limiting you to 20 points per file. We're sort of testing how this is going to work as people start using this tool. We may be able to bump that up. We just want to make sure that people can process their data at a quick and timely speed. So I'm going to show you the file that I created. The one important thing with a CSV file is that you need to have 2 columns correctly labeled as latitude and longitude. So I created a file I was just interested in sort of comparing temperatures across different cities in California. So I have my different cities, and then I have the center point for each city. And again, it's really important. You have to have these columns that are named latitude and longitude that have your geospatial information. You do need to have that in order to have this function work. So that's all the file looks like. So I'm going to browse, going to open it up, checking, file is valid, so now I can go to the next point. So you'll see that this is quite similar, but we also have a few different aggregation options that are available for this tabular download. We're going to see the top row is really the same. So once again, I can select my climate variable. Right now I want to look at maximum temperature. I can select my models. Once again, I'm going to do 4 priority models. Scenario, once again, right now I'm just going to look at this RCP 8.5. And now we have additional aggregation options. And this is something that's kind of important for users to think about. So you may recall that I said the original data is all in a daily format. We do allow additional aggregations. What I want to do is show you this help button. So I'm going to click on Aggregation Help. So we can actually aggregate data in a variety of different ways. It starts out as daily data, but we can also aggregate it into these different options, which are monthly, annual, decadal, seasonal, or water year. And this is something that's really cool. I've been looking at some of this seasonal data. Again, it's really nice. You know, one could do it. You could download the daily data and, slice and dice the data in the way that you want, but that is quite time-consuming. So it's really, really nice to have the ability to do this on the API side. But you do want to think about that what you choose makes sense. For example, if I chose my input data, temporal resolution, to be annual, it doesn't then make sense for me to say, oh, I want to create a monthly data set out of an annual data set. So we hope that this, the help helps to clarify that for people. There are going to be some combinations that just don't make sense. So you do want to think about what exactly you're choosing. So for example, if I wanted to look at decadal data, it would make sense to start with annual. So I would start with an annual resolution, and then I'm going to aggregate it to decadal. We can also, if you are uploading a Polygon file, you have some options of your spatial aggregation. This is if you're interested in looking more at the statistics of the variability of your data. For the most part, mean is the default, and that's what we would be interested in looking at. And then another thing that we have added that I'm also really excited about is an option to change the units. So most of these files are in a metric system. And we're really working with so many different file types and formats in CalAdapt. There's a lot of different units that data comes in. And we're trying to make it a little bit easier for people to choose the units that they want. Now, I will say that these options are only available for some variables. So certainly precipitation and temperature, you can choose which units you want. For some of the other data sets that are a little bit more complex, there really are not additional options. So something you might want to think about is, what are the units that the data are originally in, and do you want to change it to an imperial unit? So in order to get information on what units your data is in, you can click on this metadata information button. And this is what gives you your metadata about each of those time series. So for example, clicking on this, I see that we're in Kelvin. That's the default of this temperature. This is telling me our geographic reference system. So again, if you're a GIS user, this is something that you would want to know about. And also the spatial resolution. Right now, the data is in degrees, so that's the resolution in degrees. So I personally find that I want to work in Fahrenheit, not in Kelvin. So So what I'm going to do is change my units to imperial. Now this is all automatically going to make these changes for me to download the data. And once again, I can now download multiple files at one time. Again, I'm just going to look at 2 of them right now, just for the sake of showing you how it works. Download. All right, and we can just open them up, and I'll show you a few things. So we found, again, that this is what users really want to look at. As much as we use geospatial data here and use TIFF files, this tabular output has been really, really useful for people. So what is this data structure that it's outputting? So we'll see that it's now arranging everything in columns. And the first column is going to be our time. So you remember we did a decadal aggregation. So this is giving me, it's averaging over those annual averages for each of these 10-year chunks of time. And you'll see that I have these different columns that are numbered. So what that corresponds to is, I need to open up my original file. Which I can't get to. No, sorry, it's not there. Sorry, I'm looking for my original file. I have too many things open here. You may recall that my original CSV file is organized like this. So what happens is that it transposes our original columns. There, now we have them both open. So what this is doing is now, again, our time element is our first column. And each of these other column names corresponds in order to the names on each of my rows. So for example, Eureka is going to be, since it's in that order, sorry, having a hard time showing you this. Since Eureka is my first city, that's actually going to be my B1. So if I wanted to, I could save it out. I could type in Eureka. The next one's going to be Chico. The third one, Fresno. So that's just something I wanted people to be aware of. Again, as you're doing these multiple point locations at one time, this is how the data is going to be structured. So you might want to just be aware of how that works. And again, we could look at up to 10 or up to 20 points at one time for now. So those are some of the key features that we are really excited about. I am going to show you a few other things, but I want to, again, pause here and see if people have questions about this. I do recommend that you play around with it yourself and see all of the different options that you now have for data. So do we have some questions?
We do indeed. The first question is, what are our recommendations about working with models, choosing models? What might the GIF team say about that?
Well, our goal is really to present this scientific information and really to follow the guidelines that are set out by the state and certainly through the 4th climate change assessment. So when I talk about these 4 recommended models, these were recommended, again, by the state of California for use in the 4th climate change assessment, as showing really that range of variability in the full model set. So we recommend that people look at the full range of variability. So I would say, well, we at CalAdapt don't recommend anything. We are presenting the data that the state is recommending, if that makes sense. But normally, you want to look at a range of information. So that's why we really default to these 4 models. So I would say looking at the 4 models is a pretty good way to go.
And then one other question is, how might this tool interact with CalEnviroScreen 3.0 and the assessment of climate vulnerabilities for disadvantaged communities? Does it now? Might it in the future? What do we think there?
Right. It certainly, let's see. It certainly might in the future. That could be, well, you could get the values from Cal and ViroScreen through, you could basically, as a user, you could extract, you could have some sort of polygon file that is related to Cal and ViroScreen, and you could use those polygons to extract information and then link them together. That's a fairly standard way of working with geospatial data. We do...
we have Cal and ViroScreen too, so I don't know if the boundaries will be the same, but it's based on...
It's based on census tracts. Right. So. We will be updating, it's true, what we have right now in CalAdapt is Cal and ViroScreen 2. We will be updating to Cal and ViroScreen 3, but one could, again, sort of link the data together using whatever geospatial data set they want. Do my developers have anything else to add to that?
I guess we're thinking of the data download tool as more for the climate data sets that we host, and not for other data sets. We definitely have Cal and ViroScreen as an option in our tools, where you can look at the various climate variables within the Cal and ViroScreen, along with the Cal and ViroScreen data.
Yeah, so you can do the spatial aggregation by Cal and ViroScreen. That's one of the boundary layer options in the other tool.
Right.
And have we scheduled an update of the Cal and ViroScreen to 3.0 yet, or that's still yet to be determined when that might happen?
We haven't scheduled it, but it could happen this summer, I would say. So something that we can do before too long. Yeah.
We have had one vote from a participant for that.
Okay,
so
good to know.
Thank you.
Great.
We'll still take other questions, and if anything hasn't been clear, we'll also take clarifications too.
Great. I know we don't have too much time left. This is, let's see, I might skip ahead a little bit. I do want to point out with the data catalog, so we've looked at the LOCA data. There also are data sets on here that are station data. So I'm not going to go through the download of that, but there are data sets that are already in a point data format. So it's good for users to be aware of that. For example, we have hourly sea level projections that were, again, created for force assessment. So if that was something you were interested in, you would select that. That data set, because it's already a point data, we download that in tabular form. And you'll see that the way this works, again, it's a little bit of a different data type because it's not a raster file as an input. It is a station data set. So with the station data, what you're going to do is choose which station you're interested in. It could be all, or it could be an individual station, and then you would go about accessing the data that way. So I just wanted people to be aware of that as well. And also really quickly, before we go, another data set that I want people to be aware of. So there are some data sets that let's see. I know a lot of people are interested in our extreme heat tool. So there are some tools that we have on CalAdapt that we do additional data processing. The data processing does not take place at the API. The data processing takes place on the client computer. So an example is our extreme heat tool. So I think a lot of people are interested in that tool. Of course, you can download data directly through the extreme heat tool, as I showed you earlier. But we have had a lot of interest in that data set. So what we have done is a pre-calculated extreme heat and made that available for people. So let's see. We can look at it. Again, I just typed it in the search term, and what's coming up is this derived data set. So the LOCA data itself does not contain extreme heat. We're basically using that maximum temperature data and then counting a number of days above some threshold. So we've made that data available. Again, we pre-calculated these layers. So if you look over on the right-hand side, you'll see download data tables. So we have calculated it both for California counties and for census tracts. And the pre-calculated data is done at that 98th percentile. So this is something that users could download. And if you wanted to work with the CalEnviroScreen data, what you would basically do is download the census tracts, and then you could just link it to the census tracts in CalEnviroScreen. So that's a pretty simple process to do. So I just wanted to make people aware of that because that is something that we've had a lot of requests for. Now, if you wanted to use something other than that 98th percentile threshold, what you would want to do is, well, you could do it in the tool itself, or you could start working with that API that I mentioned. I just really quickly want to show you some of what's available in the API. So if you're interested in customizing the data even more than what we have available through the data download tool, what you can do is start working with this API directly to do even more customization. So we have a whole documentation about using the API, and we also have several cookbooks that we've written. So if you're interested in, say, for example, calculating extreme heat days with your own parameters, you can look at what we have. This is something we'll be updating soon as well. So this is probably something that's going to be changed a little bit in the future. But this really steps you through how you would do that calculation on your own end. So again, we try to allow people, we try to make it easy for people to get data that is, requested by the most people, but there's always some level of customization that goes beyond what we can make easily available. So I just wanted to point that out, that more customization is available through the API. And with that, we only have a few minutes left, so I'm going to jump back to my presentation and just quickly ask you a few questions. My settings. Okay. So with that, we are really interested in getting user feedback. So it's great that a few people asked some questions. We really would love to get more feedback. We're really excited about this new tool that we created, and we really think that it'll make it a lot easier for people to do their own. Again, you can do your own analysis. You can. If you're interested in multiple locations and comparing multiple locations, it's a lot easier to do that now. You can make your own charts and graphs to put into reports. But we'd really like to hear from you whether this tool meets your needs. Do you have other ideas or suggestions about how to improve it? One of the things that we wanted to share with everybody is that we have recently put a survey, actually let's do that again. On the main landing page on CalAdapt, we have a link to a user survey, and this is a really great place for you to share your feedback with us. So if you go to the landing page and just look down there, there's a quick survey. We really would love to get your feedback. We're trying to figure out, who's using CalAdapt, how are you using it, and what suggestions do you have for improvements, and what new tools are you looking for? So we would really love to have people fill out that survey. It shouldn't be too difficult. We've tried to make it not too onerous, so there's only a few required questions. But we really would love to get your feedback on that. You can also email us directly if you have ideas about any of these tools. But we do hope that you can spend just a few minutes to help us improve CalAdapt, and also to make sure that the tools that we're building are tools that are really going to meet your needs. So with that, again, please do go and fill out that survey. I was going to talk a little bit about some of the things that we're working on next. For example, we're working on a local climate snapshot tool that we had in the original CalAdapt. We're also working on a new sea level rise tool. So if you have any particular questions or comments on any of those tools, please feel free to let us know, and we'd love to see that in that survey as well. And with that, thank thank you so much for your time. Are there any final questions? I know our time is just about out. Anything there, Lucy? All right. Well, thank you so much for your time. Again, feel free to get in touch with us. You can email me directly, NEThomas@Berkeley, or you can always reach out to our development team at support@caladapt.org. And please do fill out the survey and let us know what we can do to improve CalAdapt. So thank you so much.